welcome to the show, The Future Now. I'm Dr. Emmanuel, and I have here with me today Dr. Sai from the Frontiers in Bioscience Institute in Orange County here in California. Dr. Sai is a well respected and well known figure in the field of anti aging, having done enormous research and published copiously also on the same subject. He founded the Frontiers in Bioscience Institute 20 years ago, and my friend John Tabachek is on the board of the Frontiers in Bioscience as a result of his deep and lasting interest on the topic of anti aging. This platform is meant to discuss topics surrounding anti aging, life extension, and the reversal of the aging process. Welcome to the show, Dr. Sai.
Thank you for inviting me.
Welcome, John.
Welcome. Thank you.
Thank you. And today we're going to start off by one of those questions that everyone wants to know. What is aging and why do we age? And is there anything that we could possibly do about reversing the process of ultimate progression towards an end?
Right. I think in order to understand why we age, we have to have a good understanding of the evolution processes. For almost 2.5 billion years since the single cell, our ancestor Luca emerged and eventually gave rise to archaea, eukaryotes, and prokaryotes. These single cells were self-serving. They were selfish. They were praying for food. They were eating. They were growing. And then ultimately they were dividing, giving to their progenies. There was no collaboration. There was no specialization. And everyone for themselves. This entire scenario changed almost 600 million years ago when a cell that was able to manufacture a ton of energy became a parasite inside the other cell that was not making as much energy. The so-called mitochondria in eukaryotes and chloroplast in plants are manufacturers of ton of energy. This production and increased ability to make energy is the new dawn of evolution, where the single cells started to evolve. They started to colonize and be specialized in a specific task, from eating, from walking, from seeing, and from hearing. So all our senses eventually emerged because of that specialization. And we went from a single cell to complicated organism that we are. So the endosymbiosis between mitochondrial chloroplast and the ancestral cell gave a boost to evolution. But unfortunately, it is associated with the dawn of aging. According to the mitochondrial hypothesis of aging, we age because just like our regular car, we have the byproduct of our regular car, CO2, we produce a significant amount of byproducts, which are called collectively as reactive oxygen species. These reactive oxygen species, they go around and damage DNA, RNA, protein, nucleus, and membranes. And at least according to this hypothesis, it is a process of oxidation that we can consider and view as the aging process. So aging process started as soon as we started to evolve, and unfortunately it's still with us today. There are two kinds of aging. One is at the level of the entire organism. So, for example, if you talk about atherosclerosis, is part of the aging process, and it comes from the idea that eating is associated with increasing fatty products in our blood that ultimately deposit in the vessel wall and make atherosclerotic plaques. It narrows our vessels. It causes less blood flow to our organs. And if it happens to obstruct the vessel, for example, in the heart or in the brain, you get a stroke. So that is part of the organismal aging process. There are other pathological things that happen, such as Alzheimer's disease, or the pancreas starts to dwindle. It doesn't produce insulin, so we get diabetes. Hypertension as a result of eating food again, especially salt, and some predisposition give us hypertension. All these diseases that we see as we age, and especially cancer, these are at the level of organism. However, there is another, and all these have an underlying processes that at the cellular level.
Cellular
And
aging.
for the cellular aging, which we call senescence, there are multiple theories that posit of why does the cell not function. One of them I refer to the mitochondrial hypothesis of aging, but there are others. For example, the end of chromosomes, telomeres, start to shorten. This shortening is associated when it reaches to a certain limit that the cell can no longer divide. So telomere shortening is another hypothesis of aging. Another one is the exhaustion of stem cells. We continuously need to replenish our dead cells. We lose a lot of cells every day in our guts, in our skin, and elsewhere. The only long-lived cells in our body are muscles and neurons. Other than them, every other cell has a lifetime. For example, red blood cells is about 3 months.
120 days.
120 days. Leukocytes, the same thing.
Same thing.
Skin also continuously sloughs off,
And sheds
makes new
and
one. So
replaces 7 days.
every time we make a stem cell, we make a duplicate copy of original cell. One is daughter cell that give rise to the differentiated cells that make up that tissue, but the original cell remains intact. However, this is associated every time that the cell divides, telomere shortens a little bit. So you make a copy of a copy of a copy, and ultimately you end up with a poor copy. So that's another idea of how aging happens. But I do disagree with all these hypotheses, whether it's stem cell exhaustion, whether it is mitochondrial dysfunction, whether it's telomere shortening, whether methylation of nucleus and epigenomic changes. I think they are all reversible, and they are symptoms and consequence of aging, and they are all reversible processes. In my laboratory, we have been able to now reverse the senescence.
We'll get to that. I just wanted to take a step back and go to the theory of telomere shortening and its relationship, whether direct or indirect, to the aging process. The telomeres, as you know, are like the tips on either end of the DNA strand, just like the plastic cover on the shoelaces that we wear. And the shorter they are, the shorter the life expectancy of the individual. But is it the rate of degradation of the telomere length that we're born with that can be stopped as to arrest the aging process? Or is it that we can rebuild already degraded telomeres and thereby lengthen lifespan?
I think both of them are true.
Mm-hmm.
I think there were at least two studies that was done. The way that the telomeres lengthen is by the catalytic activity of telomerase.
Telomerase. Right.
Yeah, there is a TERT inside that has the ability to increase the length of the chromosomes. In fact, cancer cells do this all the time. They have heightened and increased telomerase activity,
Yes.
and they never really die. They are truly immortal cells.
The cancer cells. Yes.
Cancer cells.
Right.
So they put the telomerase in the cells that were senescent, and they reverted back to normal, and they could duplicate. So the telomere shortening is not really the end. We can reverse it, right? So if you introduce telomerase into cells, you can reverse that process that it's causing the cells not to divide. And whether there is a predisposition, how fast we can shorten our chromosome, some of it is genetic. We are all coming up to this world with certain lifetime, or life expectancy, and we can get it to be worse than what is expected, or we can improve it. So if we eat, for example, the wrong food,
Right.
and we smoke and we drink alcohol, we are shortening the natural cycle that a cell could go through, because you adding damages on the top of damages that the cells can endure. So I believe that although we are all built in sort of life, is still to some extent in our hand, as we talk about later, to prolong it and not allow it to shorten. And in fact, even if shortens, I think medicine ultimately will be able to overcome these problems that we see happens inside ourselves.
It's very interesting what you're doing at the Frontiers for Bioscience. John, you've been there for 10 to 20 years now as a board
But
member.
about 10 years, yeah.
Right.
I met Cy through another industry and just would sit with him and just be fascinated of his conversation. And when he first opened the Institute, myself and some friends, we had about 100 people at the Institute for the grand opening for a talk. And Cy got up on stage or at the mic there and just kind of riffed about what his vision is, where we came from, kind of what we're doing now, and where we're going. And again, fast forward from that 10 years, a lot of what he said obviously came to fruition, but where he's talking about where we're going with not just medicine, but science
In general,
and us
yes.
as individuals. Where are we going? And I was very intrigued by that. So he and I became friends, and he asked me to become one of the board member. So I actually have an inside view of the future. And to me, that was intriguing. It's always one of these things, learning from people who know more. And so for me, whether it be dinner or just sitting there talking like we are now, just three guys, and the interest level of people I would bring into that mix was like, wow. And I've, introduced science to some brilliant scientists from corporate America, and to a person, they would pull me off to the side and said, this guy's brilliant, but what he's thinking about, a lot of people don't think about. So looking at going after aging and cancer a different way, a different path. And that's, I know enough to be dangerous, but listening to him and absorbing that. And then I go around and explain to friends of mine what's going on, where we're going. And it's just, it's a great conversation. And I enjoy that, enjoying meeting people. And here I am with two, yourself included, in this, what we're doing here is very interesting to me. So I'm coming at this not as a scientist, but as someone who is just interested in where we're going, with thirst for knowledge. And here I am with two people, and I'm going to be a sponge.
I agree with you. I mean, aging and anti-aging is the topic of the day now. I think science and society is at the stage where we're about to experience warp speed, if you will, in the use of current available technology to extend life in a meaningful way, to achieve longevity like we've never been able to before. In other words, to fulfill life's potential in a meaningful and satisfying way. There have been a lot of discoveries, the use of stem cells, the use of exosomes, eating properly, right? Mindfulness, decreasing the amount of stress in one's life, and controlling those factors which one can control in the search for a long and meaningful life. Research is ongoing, but of course there's a lot of noise out there that sometimes tends to cloud the real discoveries. And that's what we're here to do, to flesh out what really works and what can be applied and how we can apply it in our everyday actions to be able to live our best life, if you will, to quote a common verse out there now.
And a lot of this too is not going to be conventional thinking. Who unfortunately money dictates who has the megaphone,
Oh yeah,
and who could get it out here. So something like this, where we can sit here and talk about things that aren't, the way the science is talking about, something different, something unique, and that's what I think that makes this interesting.
Right. One of the things that Dr. Sai was talking about was what we put into our bodies. If we realize that our bodies are high performance super vehicles, so to speak, the fuel that we put into them ultimately affects the performance. Right? There's been a lot of focus on plant based diets, right? And the use of plant origin nutrition is the proper way to enhance one's life and to produce a better outcome. Could you talk a little bit more about what should we eat? How should we eat? How should we go about addressing that?
First, I like to address what is it that we shouldn't eat, because it's as important as what you should eat, because all of us have to eat. If you don't eat, you die. So we have to choose always between good food and bad food. So I like to first talk about what we shouldn't eat. First and most important, we have to realize that we have only three sources of energy. Our cells are able to use glucose, amino acids, and fatty acids as a source of energy. And we have the option to choose what is it that we eat. Of course, every cell, especially if it comes from an animal, unfortunately, has all of them, including saturated fat, which is bad. But we have to have better choices than meat. So my first recommendation is, and they did a study on this, they took about 1,000 mice. They separated into three groups. One group was ad libitum. It means that it could eat,
anything they want. Right.
Yeah. The second group was protein. The third group was sugar, mostly sugar.
Now,
So
the
carbohydrates.
protein arm of this three-stage study, did it differentiate between plant-based protein and
No,
animal-based protein?
it
Just
was
protein.
proteins. Yeah.
Okay.
So they found out that the mortality rate was highest in the protein group.
Higher than even the ad lib.
Yes, absolutely. The one that ate carbohydrate, they became diabetic, but they didn't die as quickly as the ones that were consuming just proteins.
They just live miserable lives.
Right. So this brings us to the question, why is it that protein is so required for life? Amino acids are the building blocks of life. But why is it that we shouldn't eat it? There was a publication a few years ago by Heinz in Cell that discusses and partly comes back to my research. It comes back to hydrogen sulfide. All of us have integrated into our body what was the most noxious gas in early Earth. Hydrogen sulfide was abundant, and it still is, and it's frozen under the oceans. In fact, if those oceans melt the hydrogen sulfide, there will be another extinction. But we have the hydrogen sulfide in our body. Originally, the cells were using hydrogen sulfide as pure energy form before oxygen existed. After Earth became an oxygen world, the hydrogen sulfide took a back seat as a fuel, but it became protector of human cells and mammalian cells and prokaryotes. Every cell has hydrogen sulfide. Even plants have hydrogen sulfide. And they use it as a protecting mechanism against damage and ravages of environment. In fact, if you put a plant in a dried state, it increases the hydrogen sulfide production. Human cells also consume the hydrogen sulfide in our body that is made by our body as a source of energy when there is not enough other forms of energy. And it happens inside the mitochondria. Hydrogen sulfide is existing in cancer cells, in stem cells, in embryonic cells at high level.
It's ubiquitous in all cells.
Yes, all cells have it.
Right.
Now, as we unfortunately age, we lose hydrogen sulfide. Gradually, the amount of hydrogen sulfide that we can produce in our body diminishes. And there are at least I know of 2 studies on longevity. The first paper was published in PNAS a few years ago. that showed in C. elegans, which is a small nematode worm, that its life is only 14 days. They increased the hydrogen sulfide. They fed these animals hydrogen sulfide. They live 60 days. In other words, their lifespan increased by multiple times. We did the same thing in human cells. We took human cells and we subjected to hydrogen sulfide. They increased their lifespan by 30%.
That's significant.
It's very significant. So hydrogen sulfide is at the heart of the protecting of the cells and not allowing aging to occur. Now, first, we have to understand the link between hydrogen sulfide and proteins. The Heinz group published a paper on the basis that the two abundant amino acids, methionine and cysteine, downregulate production of hydrogen sulfide. Mm-hmm. And every organism uses the methionine as a starting point. ATG in the nuclear codon is the same thing as methionine. Methionine is abundant in organisms that we eat, except for plants. Plants use it less often. So which animals produce it a lot and we eat a lot? Meat of cow and chicken and salmon, they have a ton of methionine and cysteine. And these are horrible amino acids. We need them, but
for building,
when you overload your body with these things, it has consequences. You're actually reducing your ability to protect yourself against the ravages and damages of nutrition. So that's the first link. The second link is, what do we do to increase our hydrogen sulfide production?
Right.
So there are a group of vegetables that allow you to have more hydrogen sulfide. The most prominent among them is garlic. Garlic has allicin. When you start to chew garlic, the lifetime of allicin is only 5 to 10 seconds. So you have to chew fresh garlic in order for it to be absorbed from mucosa and enter your blood. And unfortunately, because we have a bad odor the day after, many people prefer not to do this.
But now you can get odorless garlic.
Well, I don't know whether it has enough of the substances that exist in garlic.
That's a good question.
But if it exists, then it is fine.
I'm just thinking from a scientific perspective that maybe the efficacy of the garlic is linked to its smell.
It could be. It could be. Yeah. Now, the second thing is arugula. Mm-hmm. Arugula is a bitter herb, and you can put it in your vegetable diet. Mm-hmm. I think most supermarkets carry it. Wasabi. Wasabi is difficult to eat because it's hot. Yeah. But if you like wasabi,
I love wasabi.
Don't stop eating as much as you can.
Okay.
So cauliflower.
Right.
All these things increase your ability to make hydrogen sulfide. So I would propose that everybody put this in their diet every day.
And it's easy to do nowadays. You get cauliflower and everything. You get cauliflower-based pizza crusts. You get. They're starting to make cauliflower flour that you can put into everyday foods now,
yes.
which is actually quite good to know.
Well, once you process cauliflower or something like that, but doesn't it lose its nutritional value?
I think these things are better if you eat it raw.
Yeah.
And of course, I think to me, is delicious. You get a taste for these things. So if you continue to eat them, I think it becomes a habit. We are really made up of habits, you know.
Right.
As a child, if our mother cooks meatballs and give us meat, then obviously we think it's normal and we absorb it. And not many people after, they think about what is it that it does to their body.
Right.
It does a lot of harm.
Taste? It's all about taste.
Yeah. The meat not only has the problem with the methionine and cysteine, it also has myoglobin. Myoglobin has an iron core.
Right.
Iron is one of the worst oxidants you can put in your body. So if you eliminate first the meat, the second thing I want you to eliminate is, as I told you, carbohydrate is better than protein.
Yeah.
But you should reduce carb. You should reduce as much as you can the glucose consumption, because especially if you eat glucose, which is really in
Sugar.
fruits,
Yeah.
yeah, sometimes sugar cubes, you put it in your coffee.
Right.
These are directly and very quickly get absorbed. And once they're absorbed, what do? Well, our body has to bring down the glucose and make it and force it into cells. And that happens by insulin.
Right.
Now, the insulin and insulin growth factors, they are growth factors. They are intended to increase the glucose entry into the cell so the cell can enlarge
Grow.
and divide.
Right.
Until we are age of 18, we are growing, so it's not a problem. But after we stop growing, I think it's harming our body.
To continue
Now,
to flood it with those
exactly.
insulin growth factors that
Exactly.
promote absorption of
Exactly.
glucose. Yeah.
Now, what do we do then? We need glucose, we need some sugar, but it's better to eat carbohydrates that are complex. So it needs time to
break
digest and break down. And this way, the glucose suddenly doesn't go up immediately after
Right,
eating.
right.
In fact, glucose tolerance test is usually tested 2 hours after
2
you eat,
hours, right.
because it takes 2 hours for glucose to get our blood. Now, you want to maintain glucose during the day. You want to maintain insulin. You want to maintain your glucose as a plateau. So you don't have to start to eat when you're hungry. Eating when you're hungry is bad.
You're already behind the 8 ball.
Right.
Exactly. When you're hungry, your glucose level has dropped and insulin is low.
Yeah.
And if you do that, then suddenly after you eat, especially if you're very hungry, you eat quickly
Fast.
and then it goes up. So you want to prevent that. You don't want your glucose to go up. So what I would recommend is to eat more often, but less.
Well, you mentioned something about eating like 10 times a day.
10 times a
but
day.
just a little, bits-
Exactly.
right.
It's
Right.
exactly.
Niblets of
Yeah.
food.
Yes.
Exactly.
Of the
Because
proper food.
we're all basically geared, societal geared
Yeah.
towards breakfast, lunch, dinner.
Right.
Okay, or I'm going to skip lunch. So you're at, basically 3 meals, and so people try to even cut that down to 2. So you're basically, changing the way our norms are, which
Yes.
which is a good thing, obviously, for life.
Right. I think, again, it comes from habit. We have breakfast, lunch, and dinner, which is really wrong. I think this idea has to be abandoned. We eat very little portion every hour or 2 hours. This is much better way of eating. You don't increase your insulin. You don't increase your glucose. Now, the best really food is really unsaturated fat as a source of energy, because the glucose or amino acid enter the so-called Krebs cycle. Krebs cycle is the metabolism that happens inside our mitochondria. And unfortunately, as I said, mitochondria are great in production of ton of energy, but it's associated with a lot of garbage that is produced, ROS, or reactive oxygen species, which damages our bodies and proteins, happens as a consequence of Krebs cycle. So if you avoid to rely on Krebs cycle, you can do it 2 ways. One is by having a keto diet. A keto diet is a diet where it induces ketogenic substances,
Right.
which is really good. Alpha aminobutyric acid, 3-hydroxybutyric acid is great. In fact, I would recommend everybody to buy it from Amazon and eat it,
But
because it's
ain't
available.
those traditionally high in protein?
No, this is really
That's the
wonderful.
fat-based portion of it you're talking about.
Yeah, the 3-hydroxybutyric acid is really a magical thing. When you eat leafy vegetables, which I would recommend for a child to have about 5 grams, for an adult 20 to 25 grams. Men need more than women, because it is an essential part of your diet is fibers. There are all kind of fibers. We have it in our liver. The liver binds glucose and make glycogen, which is really a long fiber. In plants, it's cellulose, pectin, guar. These are fibers that are not digestible by our body. We don't have an enzyme to
To break
digest
them down.
cellulose.
Right.
So what happens to the cellulose is very interesting. It encourages the production of more and more microbiome, which is
Your
collectively our
gut.
fungi and the bacteria that exist in our inside our intestinal tract. As you increase these good bacteria, they nibble on cellulose, they eat cellulose, and they digest it. And as a result of that digestion, the byproduct that they produce, it is 3-hydroxyaminobutyric acid. This is really a gem because it affects your brain. It makes you happy.
Because 90% of the serotonin in the body is actually produced in the gut.
Exactly.
If you have the right microbiome,
Exactly.
you produce more serotonin, which
Exactly.
leads to the feeling of
Exactly.
feeling good.
Yes.
Right.
It also has very good influence on diabetes, on liver function, on pancreatic function. It is a must. But most people, unfortunately, they choose the bad microbiome. There is a bad microbiome, which is resulting from fermentation of glucose and also byproducts of the digestion of meat. These are horrible substances, toxic substances. Putrescin, cadaverin. They enter your blood. They make you feel horrible. In fact, the sense of well-being doesn't come from eating meat. It comes from eating vegetables. So I would highly recommend that we convert our microbiome to a great microbiome.
Well, in today's society, everything is immediate, okay? Fast food, yada. And people look for shortcuts. People don't sit there twice a day and have a salad. You know, they're on the run, and everybody wants to do things via pill, whatever. Is there, does a lot of the pills or whatever quick fixes, is there any value to that?
Yeah, there are supplements that you can take, but also it has to start with great habits.
Right.
Dietary habits has to change. Most people haven't changed their diet.
Right.
Okay, I think it's essential for everyone to listen to dietitian and understand, especially the ones that are good. They will realize that relying on vegetables is much better than relying on animal products. For example, I do not recommend that you drink milk at all. Milk is supposed to be for neonates,
Right.
for a newborn.
Of the cow.
Yeah, because
of the
it
human,
promotes
right.
growth. We don't need any more growth.
Right.
So I think you have to put away byproducts of animals and rely on plants. Now, what plants have proteins? I think
Plant-based, yeah.
plant-based proteins are the best
Right.
because the percentage of methionine and cysteine in these proteins is lower. In fact, I think bean, legumes, the peas, green peas, these are really very nice in maintaining
Sources of
life.
protein. Yeah. What
So-
about soy?
Soybean. Now, of course, as you know, soybean has been used by Japanese, and they have seen some atrophy in the brain because they consume a ton of it.
Right.
Unfortunately, it also has phytoestrogens, which are mimics of estrogen. So if a man eats a
leads to
lot
heart
of it, may
disease.
affect his
His
manhood.
heart,
So
right.
I would recommend it, but I think bean is very good. Now, some people have bloating.
Right.
Now, if you want to prevent bloating, there are two things you can do. First, put the bean or lentils or peas in water for 1 or 2 days. Change the water, so most of the things that causes bloating will go away.
Right.
And then, if you're really, really desperate, you can buy Beano, which is an enzyme that breaks down
That breaks
what
down
causes
the
bloating.
gases, right?
So-
It brings me to a point like the World Health Organization recently released a study condemning the continuous media bombardment of youth with the advertisements, right, geared towards getting them to eat the wrong things.
Well, I think the younger generation now are savvier in reaching out to Google and finding out what nutrition they have to really follow. But I think there is a tremendous amount of avalanche of medical knowledge that says what to eat, what not to eat. And on the same token, there are other things we shouldn't do. Salt. Don't put too much salt in your food. I think there are a tremendous number of seasoning that you can put in food. In fact, I do that. I do cook, and I don't use salt at all.
What about rock salt or sea salt?
Sea salt.
Yeah, it is the same thing. It's the
Himalayan
same
salt.
sodium chloride. So you have to avoid sodium salt by all
means.
possibility.
Right.
The reason is there have been studies that shows that it increase the possibility of colon cancer. So if you want to reduce it, don't eat meat, don't eat
Salt.
alcohol. Alcohol damages your liver. Liver is the most important vital organ besides brain and heart. If you damage it, you're shortening your life. I would recommend, though, that you drink a glass of red wine. According to some studies, and some people oppose it, resveratrol, which is active antioxidant in the grapes, it's really useful as an antioxidant. In addition, I would say if you want to eat fruits, grapes, take the juice out. Just eat the skin.
So the dry, or you should
Yeah,
dehydrate them. then.
Yeah, so the juicers are doing the opposite.
Right.
They
right.
take the juice and you drink the juice and you throw
Throw
away
away
the
the
best
seed.
product.
So
which is the
basically, you should
fiber.
do just the opposite.
Absolutely.
Yeah, okay.
Absolutely.
Use
It's
the
not
juicer.
common sense, but then
Yeah.
when you understand, we have 2.5 kilogram of bacteria and fungi in our gut. 2.5 kilogram is equivalent to an embryo. We have an embryo in our body,
In the gut.
right?
We're all
So
pregnant.
Yeah.
how is it possible
Yeah.
that such? I mean, liver is also the same weight. Liver is the most important function. Now, sometimes we say gut feeling. It's true.
It's true.
The microbiome has a direct link to our brain. As I mentioned to you, one of the linkages through 3-hydroxybutyrate, right? So you really want to take care of your microbiome.
Yeah.
They give you life. They prolong your life. They make your happier and healthy life. You should adopt that kind of life instead of eating animal fat and animal meat. Now, what else we shouldn't do? Cigarette smoking, horrible. Cigarette smoking damages your lung, and as you decrease the capacity of lung to give you oxygen, obviously you will.
So
you
now
will
the hip
shorten it.
thing is all these younger kids now they're vaping.
Yeah,
So
they-
they think that's
right.
safer.
No,
But
no. For
It's
vaping
switching
is-
one evil for the other.
Exactly,
Right.
exactly. It's just a
What
different
it's saying
delivery
that
system.
It should abstain.
yes. Yeah.
Abstinence is the thing.
Well,
Right.
no,
Right.
nobody, not many people are monks. Okay, everybody has their vices, but having a good steak once in a while, or
Right.
have you're saying stay 100%
because it becomes habit. We are the byproduct of our habits in our childhood.
that my question was everything in moderation.
Right.
Can you have a burger once a week, once a month, a steak, or you just saying
I prefer that you don't, but if it is your wishes, of course you can do that. But my idea is really to give you the blueprint of long life. Okay. Now, if you want to deviate it from sometimes because you're bored, that's okay. But I only give you the blueprint. Now, it is up to you to decide how to abide by that blueprint. Now, one more thing that you really have to avoid is obesity. Now, everyone can buy a scale for $30. Every day, weigh yourself, and don't let that gauge go higher and higher and higher, because that's the worst thing you can do.
are you the one that told me you never see old people who are overweight?
Exactly. You never
if
see a
you're
90-year-old
yeah.
obese man or woman.
Yeah.
Ever.
However, there was a study though that showed that people who are overweight who get to that age tend to live longer.
What I have never seen any
They
90
do
or
exist.
100-year-old man.
If you define obesity as a BMI over, let's say, 25, 28,
Yeah.
right, they do exist.
Well,
Going by BMI calculations, they do. But
Would
the
that be
studies,
the exception
right,
versus
the studies show that those who get to 70, 80, a
Big.
bit overweight, tend to live longer.
Oh,
Now,
Would that, but again, over years, if your BMI is X, over, it just puts more strain because
It does.
your
It
blood
does.
has to
It
pump
does.
more. So,
And again, there are different things to look at when you're looking
and
at that study.
genetically, people are
Right,
different.
exactly. When you're looking at that study, like just getting to that stage, being overweight is unlikely.
Yeah.
But if you do get to that stage and overweight,
But-
in other words, don't try and crash diet and lose weight at
Right.
70 or
But
so.
imagine if he had a twin brother and that twin brother was thinner, would he live longer than his obese brother? My answer is yes.
Right.
Now, genetics
Or probably.
genetics are a significant role in your life's expectancy. However, I think, as John said, if you have more cells to take care of, then
Yeah,
obviously you
yeah.
have more energy,
And
you
you
have to
need
put
more
more nutrition,
resources, yeah.
you have to put
Yeah.
more.
You're working that engine harder.
Exactly.
Mhm, right. Mhm.
Now, one of the things that happens to most of us is that our pancreas eventually give up making insulin. Now, every pancreas has a expectancy,
Lifespan.
life
Lifespan,
expectancy
right.
is a machine.
It's like a battery.
Exactly. So you can choose to use it in 20 years
And burn it out.
die,
Right.
or you can expand that to 80 years or 90 years or 100 years, and then it will do still function. You may become
Well, you brought up
pre-diabetic.
the subject that we were talking over there at the coffee shop about cancer. At some point in time, if you live long enough, you will get cancer.
You're gonna get something.
Yeah. So pushing that back longer by these healthy lifestyles.
Yeah.
So I'm going to deviate here a little bit. Talking about meat. Now there's the big kick right now is all these plant-based meats.
Yes.
So you have plants, you're forming into making it look, taste, smell like a burger, but now you're cooking it. You're now getting these plants and you're frying it. You're putting a little oil. You're making it taste like meat. Is there a benefit to that? I know probably more than just a burger, made out of a cow, versus something that is, now being manufactured as a
Yeah.
plant.
I'm not a big fan of those, really.
I mean, is there if you would eat a salad, obviously that's a lot better. But is there any real benefit to this? I know this is somewhat controversial right now because that's the big push right now.
It's like a quarterback sneak. It's like the vaping.
Yeah.
The vaping
Okay.
tobacco of the meat. Then, if you're not going to eat meat, stay away from meat substitutes. Right.
Eat veggies.
Eat
Yeah.
veggies. Right.
I haven't had meat for 40 years, and I don't want to have meat. I don't desire it. I think it's a habit. If you just kick the habit overnight, it's better.
Well, that's the thing too. Enjoyment. Some people
Right.
it just
What's the
smells.
use of living? if
Yeah,
you
yeah,
use
so-
that?
You have eaten my food. You know it tastes
It
great.
tastes good. Yeah. All right.